An app state is any value that can change over time. State is updated in response to events. Events are inputs generated from outside or inside an application, such as pressing a button, sensors sending a new values, or network response, like in our example, using a text field, changing our input strings using our keyboard. An event changes our state and the state updated, then the user interface is updated to display the new state. For example, using text field, using a variable, call it my string, okay, and equal initial value, call it hi, and our text field value equal to my string. Check our preview, okay, and using label variable, label equal, so text name, check preview, and on value change equal my string equal it. Let us run our app and using a keyboard for writing any word in our text field as shown, nothing happens because you haven't told Compose that it should redraw the screen. Compose needs to know what state to track so that when it receives an update, it can schedule the recomposition or redraw the screen using mutable state to make state observable. Here, I string equal mutable state of and using initial value. Okay, and here we dot value. Okay, any change in our mutable state variable my strings, our compose receives that state updated and schedule the recomposition. Let us run our app again and try to write any word using our keyboard. Notice that nothing happens again. The reason for that schedule recomposition is working fine, but when recomposition happens, the variable my string reinitialize it to our initialize value high. We need a way to preserve this value across recomposition. We can do this using remember composable function. Okay, and statement. Run our app again. You notice that our state is updated and user interface updated. Writing any word. In our example, we used immutable state as observable type to hold state. Campus support other observable types like live view, state flow, and Rx Java's observable. To allow Campus to use this state and automatically recompose when the state changes, you need to map this types to state of type T. For flow, using collect as a state with lifecycle, collects value from a flow in a lifecycle aware manner, and also collect as a state is similar to collect as a state with lifecycle. It also collect values from flow and transforms it into compose state. For live data, using observe as state starts observing this live data and represents its value via state, and also Rx Java 2 using subscribe as state and Rx Java 3 subscribe as state.